Mode is a part of ventilator settings. Ventilator settings are the operator's commands to the ventilator. They define how the ventilator should perform. It is often necessary to modify the settings when the patient's clinical condition or therapeutic strategy change. There are several categories of ventilator settings, each defines a specific aspect of ventilator operation. Common ventilator settings are ventilation mode, control parameters, and alarm limits. Mechanical ventilation therapy is optimal only when all settings are appropriate. What is a ventilation mode? Most ventilators today share a common operation principle, intermittent positive pressure ventilation, IPPV. In this module, we will focus on ventilation modes with this principle only. Intermittent positive pressure ventilation is realized in form of a series of mechanical breaths delivered by a ventilator system. As we learned in the last module, essential variables and mechanical breath types, there are 8 types of mechanical breaths. A ventilator system performs very differently, dependent on the deployed breath type and their sequences. A ventilation mode is defined as a set of predefined breath type or types and sequence. Every mode has its own intended applications. A modern ventilator usually provides several ventilation modes to meet various clinical conditions. Only one mode can be used at a time. When you select a mode, it means that you consider it to be the most suitable for this patient now. The ventilator simply obeys your order. We will discuss mode selection in depth in section 11, bedside mode selection. Modes and control parameters. Control parameters, or simply controls, are another category of ventilator settings. Modes are designed to define the breath type and sequence, while controls define the main properties of the defined breaths, including triggering, cycling, controlling, targeting, baseline pressure and FiO2. Every mode has a unique set of controls. Controls can be roughly classified into 3 groups, those for ventilation, those for oxygenation, and those for synchronization. The table shows the common controls in each group. A modern ventilator usually has a default mode and its default control settings. The defaults are designed for quick start of mechanical ventilation. Yet, if not in a hurry, you should set the mode and controls individually for each patient. Why so many modes? It is hard to tell the total number of ventilation modes. According to Chatburn, a top expert and educator in mechanical ventilation, there are 174 unique names for modes of ventilation. Why do we have so many modes? This phenomenon comes mainly from the technological evolution and non-standard nomenclature. At the very beginning, ventilator design was simple and rigid. Ventilators worked well only in a passive physical model. When a ventilated patient breathed actively or his or her clinical condition changed, asynchrony was inevitable. If this occurred, the operator only had 2 options, either to adjust the settings around the clock or to suppress the spontaneous breaths. Neither is a good option. To solve this problem, the ventilator industry constantly introduced new modes, some useful and some less useful. Only a few good ones stand the test of time. Naming of ventilation modes is not globally standardized. Ventilator manufacturers are free to name the modes in their ventilators. Here we need to differentiate between unique mode names and unique modes. The number of unique mode names is much bigger than that of unique modes. The worst scenarios are that one unique mode has different unique mode names, and that one unique mode name is used for different unique modes. A name is just a label for identification. If a name fails to do this, we have to analyze the primary characteristics to differentiate one subject from the others. If it walks like a duck, quacks like a duck and looks like a duck, it must be a duck. In terms of ventilation modes, the characteristics are breath type and sequences.